Hey Finxters, what's up? It's Chris, founder of Finxter.com, and in today's video I thought it would be fun to discuss how to find non-secure HTTP URLs as part of my Python OneLiners book launch process. So the book has already launched a few months ago, but I'll still have some videos to go. I promised to create like 60 videos, one video for each chapter. So therefore I thought it would be fun to have one one-liner video today. So in today's one-liner you will learn how to solve one of those small time-intensive problems that web developers often run into. So say you own your own blog, say a programming blog like Finxter.com, and you have just moved your website from the unsecure protocol HTTP to the more secure protocol HTTPS. And however, your old articles still point to the old URLs. So as a programmer, what do? You write a small script to find all occurrences of the old URLs that still point to HTTP. So the S extension of HTTPS means that it is encrypted, so it's a more secure version of the HTTP protocol. So therefore, like the web requests are encrypted on the way to the web server. So therefore, no third party, no man in the middle could eavesdrop on the communication between you and your web server. Good. So, and in the preceding regular expression videos in this one-liner series, you have learned how to use the square bracket notation to specify an arbitrary range of characters. Okay, so we will use the re engine, and you have learned about like this expression. This one defines match one character out of the range of characters from A to Z. And and you can use the character set, it's very powerful. You can also write regular expressions like this: match all characters or match all occurrences of characters between 0 and 3, so that basically are numbers between 0 and 3, but as character strings, or A to C. Okay, so this one would match, for example, this would match the character A, this would match the character C, this would match the character 3 and the character 0, for example. Yeah, so this would be some valid matches for this character class. And this way you can craft regular expressions. You can find regular expression in texts. It's a very powerful use, this character set. Okay, so but let's dive right into the problem. Okay, so given the following data, I'll just copy paste this. So we have an article, yeah, like this could be any blog article. In our scenario, you have a web blog. You can automatically scrap all the blogs from your website and analyze your own blogs and find all occurrences of old links like HTTP links, and say we have an article. The algorithm has important practical applications. Then we have a link, HTTP, blog Finxter.com applications. So there's an S missing, it is not non-secure yet. Then we have also another occurrences, but this one would not be a valid URL. So this one doesn't have a top level URL like .com, a top level domain, or .de or .co.uk, for example. So it doesn't have this top level URL. So we don't want to match this one. We don't want to match. Yes, we want to match this one because this is a valid URL. It can have an arbitrary number of subdomains with this dot separated subdomains. This one also would be a valid URL with a trailing backslash. This one is also a valid URL with a trailing minus and a backslash. But yeah, this one is not a valid URL, and this one is already an HTTPS one, so this should not be matched. Okay, and our goal is to find all occurrences of URLs in our article that use this non-secure HTTP protocol. So how do we do this? In a single line of code. This of course is a restriction. Otherwise it would be quite simple. Okay, so we create a variable. Let's first get rid of my face here. Okay, a variable called stale links, and we store all stale links in using our one-liner expression. We use the find all function. The find all function returns a list of matches in our text. Okay, this is exactly what we want. We want to find a list of matches. So then for the find all function, we need to define the regular expression pattern to be matched and the article in which we want to match the pattern or the text. Yeah, and the article, now this is already our variable article. This is a text in which we want to match our pattern. So now we simply need to define the pattern of old or stale URLs that should be replaced with a newer one, with the HTTPS protocol. So how does it work? So we define our pattern within a string and we use HTTP. So we first want to match an occurrence of HTTP : // So this is basically, this one was not a valid URL, sorry, because it had only one front slash and not two front slash. We are looking for this protocol start, because with this two front slash slashes, this is like HTTP : two front slashes. This is the introduction of our insecure protocol. Everything else is actually not a match. So it should start with this string. But then we have an arbitrary number of characters between A and Z, 0 and 9, and we have the underscore. We even have the minus and the dot. So we need to escape the minus, because in the character class the minus means the whole range between two symbols. Okay, so for example here we have the A to Z. So the minus symbol within a character class, within the square bracket notation character class, in our regular expression means from to. Okay, so therefore here, if we want to match the minus itself, so for example here we want to match the minus, we need to escape the minus using this single backslash, and the single backslash then removes the special meaning from the minus within the character class. Then we have the dot. The dot doesn't have a special meaning within the character class, so it just matches the dot symbol. It has a special meaning outside the character class, but this is not critical to understand here. Okay, so in this whole thing, this whole character class, it only matches one character. So the character class is like an OR operation. So match either this character or that character or that character or everything in between. So match either one, but only one single character. So this whole thing matches only one character. So we want to match an arbitrary number of those. Yeah. So this one will match an arbitrary number of symbols between 0 and 9, between A and Z, minuses and dots. Arbitrary number of dots. So this would, for example, match all this whole thing, basically. Yeah. And then we need to match we require to match at least one dot. This is what we require, yeah? So this one would also match, say, this part, yeah? So this whole would match this part, so therefore this would be a valid match, but this is not a valid URL because it doesn't contain a single dot. So we require to match at least a single dot. So therefore we write it like this, okay? So we write a single dot, but we need to escape the dot now. Outside of the character class, the dot has a special meaning, and it means match an arbitrary character. So we need to escape the special meaning because we don't want to match an arbitrary character. So just writing the dot here would be a mistake, because then it would match an arbitrary character, not the dot. It would also match a dot, but it would also match other characters. So therefore, this one would in the end just match the L as an arbitrary character, and it would return, okay, this one is actually a valid URL, but this is not. So we need to match the dot. If there is no dot, we don't want to match it. So therefore, we escape the dot symbol and we match one dot. So therefore now this would already rule out this URL as a valid URL. But then of course it would also rule out all other URLs, because now the regular expression pattern as it stands here just matches all these URLs that end in a dot. But there is actually no URL that ends in a dot, right? So therefore we need to match one more thing, basically an arbitrary number of those characters. Okay, so now this one, so this is just a copy paste, it's just the same as before, but now it has one difference. Instead of the dot, because we don't want to match a dot anymore, so this dot should match the final possible dot in our regular expression and our text. So we want to find, so this part here would matches any dot, but only if this is the last dot that occurs in the regular expression, yeah? And therefore, it shouldn't be possible for the regular expression engine to find another match now. So then if we like construct it this way, then this will always match to the last dot. So we match an arbitrary number of symbols between A and Z, between 0 and 9, underscore, and the minus. Also we match a minus. This is possible here, for example, minus. And we also want to match, we want to be able to match a front slash, because we also can have URLs like this. Yeah, so we can have this arbitrary number of URLs. We can even end in the front slash. So after we have matched the top level domain, we have this whole path information on this given URL. So therefore we also match the front slash here. And we don't match the dot anymore because we have already matched all occurrences of the dot, but the last one we have matched here, and so therefore we don't need to match any dot anymore. Okay, and that's it. That's our regular expression pattern. Let's execute this. Let's refresh our shell. Okay, we need to print something, otherwise nothing happens. Stay links. Okay, we have matched HTTP blog Finxter.com application. This is a valid link at HTTP protocol. You see all of the matches are HTTP, so this has already worked out. We have matched even with trailing front slashes. We have matched everything. Actually, we have matched these complicated high-level domains. So we have matched all occurrences of the insecure URLs used in our article in a single line of Python code. This was like the master line. So there you see, if you master regular expressions, your capability as a OneLiner expert, as a coder who is proficient in the use of the Python OneLiner superpower, has increased dramatically. So keep studying the regular expression packages. We have actually 2 books at Finxter that teach regular expressions. The first one is Python OneLiners, which you have already seen. You can check it out, Python OneLiners. It's now top 20 open source book, open source programming book in the world. So it has like finally reached the bestseller position. But we also have a second book which focuses much more in much more depth on regular expression. It's called Learn Regular Expressions the Smart Way. The smartest way to learn regular expressions. So I have written some books now, and I'm somehow confused about the titles. Okay, so the smartest way to learn regular expressions. So there's another book called A Smarter Way to Learn Python. I think it's like this, the title is A Smarter Way to Learn Python. So we thought, okay, if there's a book titled A Smarter Way to Learn Python, then we need to write this book, The Smartest Way to Learn Python, Regular Expressions, and we are focused on regular expressions. So it's like a natural progression. We needed to write this book only because of the title, and therefore, I mean, we published the book, and it's a like innovative three step approach. So in each chapter we first teach you the chapter, we give you a puzzle, and we also give you a video link that you can click and then watch the introduction. Like from I'm explaining all the concepts in the book, all the content in the chapter in a video format. So this is a great way of for you to learn. Very interactive book. So also check it out. I will also give links in the description to both books. Thanks for watching this video, and see you in the next video. Bye.